Good afternoon, students. So, whether my screen is visible, I am audible.
Yes, sir.
Okay, right. So, welcome to the module 28, the ICE engine subject. In this class, we are going to see about the supercharging and the turbocharging. Right. So, last class I already discussed what is supercharger and what is supercharging. Right. So, the supercharging, it's a compressor like a device, right? It's the compressor like a device, right? So which creates the pressure, right? Which will increases the pressure of a inlet air, right? So what will happen? So it will pushes the air into the cylinder in the combustion chamber, right? So the mass flow rate will be high. At the same time, the density of the air will be high, right? So if the mass flow rate will be high, so it will contains a greater amount of oxygen, right? So which is present in the atmospheric air, right? So if the oxygen content will be more, it is very easier to burn the fuel, right? It is easier to burn the fuel, right? So the combustion will be taking place in very good manner, so better combustion will be occurs, right? So due to the higher amount of the airflow, higher amount of oxygen which is present in the atmospheric air, so we can get the better combustion. So automatically we can get the more power output and the efficiency also, right? So that terming is called the supercharging, right? So that terming is called the supercharging, and that device is called the supercharger, right? So here you can see the 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 atmospheric air will be passing through this filter, so it will remove the dust, it removes the unwanted particles in the air, so it will filters and it will gives the pure air into the tube, that manifold, and it will be goes into the compressor chamber, right? So it is the supercharger, right? So fourth one is the supercharger, and the supercharger will compress the air, and it will increases the pressure, and it will send to the engine, right? It sends to the combustion chamber, right? So the combustion chamber, sorry, so the energy output, right? So how the compressor, how the superchargers will be run means through the belt drive, which is connected from the crankshaft. So the here in this diagram, you can see the supercharger will runs, right? Will runs through a belt which is connected to the crankshaft. So it will gets the energy, right? It will get the energy from the crankshaft itself. So it will get the energy from the engine itself, right? So by the method, right? So where the superchargers will be arranged, right? So how it will be works, right? So depending upon that, we have some methods or the arrangement of the supercharging, right? So we have 4 or 5 types of the methods, right? So the first one is the compressor, which is driven by the engine, right? So the compressor is driven by engine, right? So here you can see in the diagram itself, we can easily state the method, right? Sorry. So in this arrangement, you can see the compressor is driven by the engine with the help of the gear or a belt one, right? So the compressor will runs with the help of the gears or a belt drive, right? So the certain engine output is used to run the supercharger or a compressor, right? So in this case, the output of the supercharged engine is greater than the gross output, right? So the net output of the supercharged engine is greater than the gross output of the naturally aspired engine, right? So the net output increases due to the supercharging is obtained by the subtracting this power from the gross output. So the air cooler is used, right? So here the air cooler is used after the compressor, and to reduce the inlet temperature of the air, to reduce the inlet temperature of the air, so we are using the air cooler, right? So we are using the air cooler. So um, it will reduces the inlet temperature of the air to the system, to the engine. So it will reduces the knocking and it will improve the engine performance, right? So this is the first method, right? This is the first method. So the compressor is driven by the engine, so either in a gear drive or a belt drive. Then the second one, right? So in this arrangement, the supercharger is driven by the turbine, right? So which runs with the help of the exhaust gas from coming out from the engine, right? So the exhaust gas, right? So it releases the gas, right? So that gas will be passing through the through the turbine and it will go to the exhaust, right? It will go to the out system, right? So due to this, right? So due to the exhaust gas, what will happen? The turbine will be rotates, right? So while the turbine rotates, this it will develop the power that will be input to the compressor, right? So in this case, the engine output is not utilized to drive the compressor or a supercharger, right? So there is no mechanical connection between the engine and the supercharger. But here we can see there is the connection between the turbine and the compressor, right? So this type of compressor, this type of the supercharger is called as the turbo supercharger, right? This type of supercharger is called as the turbo superchargers. Why? Because so in one more thing will be there, right? So there is turbocharging. There is one important term that is called the turbo charging, right? So it is a very important one. Why? Because so the next topic we can see the turbocharging, right? So the exhaust gas, right? So the exhaust gas which is coming from out to the engine, right? So that gas will passing through the turbine. So what will happen? The turbine will be rotates. The turbine will be rotates, and the exhaust gas will be passing through the atmosphere, right? So while it will rotate the turbine, so what will happen? That energy will be utilized by the supercharger. That energy will be utilized by the supercharger. So there is no mechanical connection. There is no connection between the engine and the supercharger, right? So the supercharger will be works by the turbine, right, which is connected in the line of the exhaust system, right? So this type of system is called the turbocharging. This type of system is called the turbocharging, bro. So especially this one is called as the turbocharger, right? So turbo supercharged, right? This type of engine is called turbo supercharged engine. The third one, right? So it's very simple one, right? So in this arrangement, the supercharger is either driven by the engine or sorry, it will sorry in this type. So this type of superchargers, the supercharger will be driven by the electrical motor, so not by the engine, not by the turbine, right? So it is a separate unit, right? So the electrical motor will be drives the compressor, drives the supercharger in different manner, right? So the separate manner. So we have required the external source for the electrical motor. So this one type of the method of the supercharging. And here, so in this arrangement, the power is produced by the engine is utilized to run only for the compressor, right? So only, sorry, what is it? The power produced by the engine is utilized only to run the compressor, right? So the exhaust gas coming out from the engine is utilized to run the turbine, right? So here you can see that we have using the two terms, right? Superchargers, right? Here we are using the supercharger and here we are using the turbine, right? So the engine will runs, right? The engine will runs the supercharger and the exhaust gas will runs the turbine, right? So there is no connection between the engine and the turbine, right? So this type of arrangement is known as the generator type supercharging, right? This type of um, but this method of supercharging is called a generator type supercharging, right? So that you have to remember. Then the last one is the direct coupling between the engine, turbine, and the compressor, right? So in this arrangement, you can see all the three, the compressor, engine, and the turbine, all coupled together, and with help of the gearing or a belt one, right? So most of the time it will be coupled with the gear, right? So in this case, if the power, the turbine output is not enough to run the supercharger, right, during some part of the engine, right? So the engine power takes care of the remaining load which is produced by the turbine, right? So if the supercharger will runs by using the turbine, so the turbine energy will not be sufficient to run the supercharger or a compressor, right? So on the time, what will happen? We have to utilize some energy from the engine also, from energy from the, sorry, remaining energy from the engine also, right? So we can get the extra power, we can get some additional power from the turbine and the engine to run the compressor or a supercharger, right? So we have five methods of the supercharging, right? Then then we have some advantages, right? So what are the advantages are there? There's, you can read this one, right? So the higher mass charge, right? Higher mass of the charge, and hence the higher volumetric efficiency, and it will increase the power output. So the better torque characteristics over the while uh, wide range of the speeds, right? Then the ratio of the weight to the power engine is will be reduced. Then the better mixing, better combustion will be taking place, and the scavengings, right? And the superchargers do not suffer a lag, right? So the ignition lag will be very less. So the engine response is very good, right? Then the CI engine, the supercharging makes a better atomization of the fuel and the vaporization. So the knocking tendency will be very less, right? So the more complicated and smoother combustion, right? So it will be very good. So the for the specific fuel consumptions, right? And it will improve while starting off the cold starting, right? While the disadvantage of the CI engines most of the time is the cold starting conditions, right? So it will avoid the cold starting conditions too, and it will reduces the engine emissions, that is the exhaust smoke, right? So the superchargers, it can be uh, bolted on the top of and side of the engine, right? So most of the time the top side of the engine we can install this one, right? So it is very easier to cheap, and it is very easier to maintain, right? So this type of these are the advantages of the supercharging. And the same time we have some disadvantages also, right? So the superchargers require some power, right? So which is taken from the engine, so the engine will generate some more power. The whole power will not be used for the load conditions, right? Some power will be used for to run these type of the accessories, right? So it is a major disadvantage, right? So for example, if you have an AC, right? So in your car you have an AC, right? So if you put AC, what will happen? Automatically the mileage will be reduces. Why? So the power, right? So the power will be generated from the engine, right? So it will not be used, it will not utilized 100% to the driven of that car, right? So most probably the accessories, right? The AC, right? So some power will be utilized by the AC. So what will happen? Automatically the mileage will be reduces, right? So that type of the disadvantages will be there, right? So in most of cases, if you are using the accessories, right? If you are using the accessories, so what is the accessory? It will increase the engine performance, right? So that engine performance will get uh, the engine performance will be utilized to run the accessories terms also, right? So that's a very major disadvantage for the supercharging and the turbochargings, right? So these are main disadvantages for the supercharging, right? Then the second one is the important one, right? So we already told that the what is supercharging, and here you can see the turbocharging, right? So by using the exhaust gas, right? By using the exhaust gas, right? So from the engine itself, it will create the exhaust gas will be produced, and that exhaust gas will be passing through the exhaust manifold, and it will be passes through the atmospheric, right? So meanwhile, right, from the engine and the atmosphere, the silencer, right? So the turbine will be runs with from the engine, right? So it is produced from the engine. So what will happen? The turbine will be turbine, right? So that turbine some elements in the engine, right? Some elements in the engine. So especially for superchargers, right? The compressors, right? So the compressors will be working with the energy, right? Where it can be produced from. Is produced from the engine, right? So the turbocharging, right? The type of system is called the turbocharger. So in this turbocharging, right? So the exhaust gas from the engine to run the turbine, right? So what will happen? The turbine turns, right? The turbine will be rotates. So while rotating the turbine, its speed will be somewhat low, right? So but we have to run the superchargers. It will require the more speed, right? More RPM will be required to run the supercharger. So what will happen? We have to give some gear arrangements, right? So from the larger gear to we have to shift into a smaller gear, so the RPM will be increases, right? So the turbine of the supercharger will rotate the speed about 1,50,000 RPM, right? 1,50,000 RPM, right? So here you can see, right? uh, in this, the brown color will be the exhaust one, right? So the brown color will be the exhaust one and blue color will be the inlet air, right? So you can see the ninth one is the filter, ninth one is the filter, and eighth one is the inlet manifold of the air, right? So that air will be goes through the sixth one. You can see the sixth one is the impeller, and the fifth one is the turbine part, right? So what will happen? The atmospheric air will be sucked by the filter and it will be passing through the turbine, and from the turbine it will be goes into the system, right? It will be goes into the system. You can see here, right? So it will be goes into the system, right? Is it clear or not? Right. Then how the turbine will be runs, right? So here you can see the fourth one is the here the turbine will be there, right? So whether you can see this animation, anyone?
Yes, sir.
Yes, right. So you can see the exhaust gas will be passing through this turbine. So what will happen? So the exhaust gas will be coming out from the pressure and the velocity, right? That will be utilized to run the turbine, right? So once it will be it will be runs the turbine, right? So the turbine will be get some power output, right? It will get some rotor, right? So the rotor will be rotates and we can get some power, right? So due to that power, right? Due to the power, what will happen? The turbine will be runs, and the runs of the turbine it will generate the power. That power will be supplies to the supercharger, right? So here, just wait. Right. So here you can see this shade is the supercharger, right? And here it is the turbine one, right? So the turbine runs, right? So this type of the engine is called the turbo supercharged engine. This type of engine is called turbo supercharged engine, right? So you know, right? Now you know the difference between what is supercharging and what is turbocharging, right? Do you understand the concept, right? Have you understood? Anyone?
Yes, sir.
What is what is supercharging and what is turbocharging? Right? So here also we have some advantages and disadvantages of the turbocharging, right? So for the advantage, right, it will increase the power of an engine, right? So at the same size of the engine, we can increase the power, right? And it will reduces the size of the engine for the same output also, right? And it will reduces the specific fuel consumptions, right? And it will improves, right, due to the less cylinders and the greater air supply in, and we can utilize the exhaust gas to run the turbine, right? So the thermal loading is reduced due to the shorter and more efficient burning period for the fuel, right? Which leads the less expanding the cylinders condition, right? So these are the advantages, and we have some disadvantages also, right? So the special exhaust manifold is required to for the connection of the exhaust manifold, and it will be passing through the turbine, and we have to again we have to pass the exhaust gas from the turbine to the atmospheric. So we require some extra manifold, right? We required special manifolds, right? And the major problem, right, in the turbocharger is we do not the intermediate the power boost, right? So immediately we can't get the power boost, right? So it may take some time, right, to run the turbine, and it will get the power from the supercharger, and we can get some maximum power output, right? So that is called the turbo lag. That is called the turbo lag, right? So it's an important 2 mark question, right? So what is the turbo lag, right? You can remember this one. So what is the turbo lag, right? So even though you can feel this one, right? So in the starting of the engine, in the starting of the car, right? So you can put the AC and you can start the car and you can run, right? So the engine will be having some difficulty to run the car, right? Is it right or not? Anyone? இப்போ நீ கார் ஸ்டார்ட் பண்ணிட்டு போயிட்டு இருக்க அப்படின்னா, இப்போ நீ கார் ஸ்டார்ட் பண்ணோடனே இங்கே ஏசி ஃபுல்லா வச்சு நீ காரை மூவ் பண்ணி பாருங்க, அது மூவ் ஆகிறது கொஞ்சம் கஷ்டமா தான் இருக்கும், ரைட்? இட் வில் டேக் சம் எக்ஸ்ட்ரா பவர், ரைட்? ஸோ இதே நீ கார் கொஞ்சம் மூவ் ஆயிட்ட பிறகு நீ கொஞ்சம் ஏசி போட்ட அப்படின்னா இட் வில் ரன் ஸ்மூத்லி, ரைட்டா? ஸோ இட் கேன் டேக் சம் delay, right? That delay is called the turbo lag, right? That delay is called the turbo lag. So what? So the power boost, we cannot get the power boost immediately, right? So we can give some time to generate the power, right? So that time period is called the turbo lag, right? So these are all the disadvantages of the turbochargers. And here also we have some methods for the turbocharging, that is the arrangements, right? So how the exhaust gas will be passing through the turbine system, right? So here we have the constant pressure turbocharging, pulse turbocharging, and pulse converter, right? In this you can see the diagram, right? So the um, constant pressure turbocharging, right? So the exhaust gases are we are using the multi-cylinder gases, right? So the exhaust from the various cylinders, right, discharge into a common manifold, right? So at the pressure, right, at the pressure will be higher than the atmospheric pressure, right? Is it correct or not? So the pressure will be higher than the atmospheric pressure. So the exhaust gas from the all the expander in the exhaust valves, right, to the approximately constant pressure output, right? So this type of the turbocharging is called the constant pressure turbocharging, right? So the exhaust gases are maintained at a constant pressure during the whole cycle of the engine, right? So the pure reaction, right? The pure reaction turbine can be used here, right? So do you know what is the reaction turbine? What is the impulse turbine? அதெல்லாம் படிச்சிருக்கீங்களா இல்லையாப்பா? Reaction turbine and impulse turbine. Say replay whether you studied or not. Yes, you studied, right? So here we are using the reaction turbine, right? Here we are using the reaction turbine, and here we have some advantages and disadvantages also, right? So you can see the advantages and the disadvantages. So the exhaust piping in the it's very simple, right? And for the multi-cylinder engines as well as the single-cylinder engines too, right? So and it will create a higher efficiency, right? It will create the higher efficiency. We can obtain the higher efficient turbine. It can be used here, right? And the pressure ratio is used is higher in the compressor and the turbine, right? So hence the recovery of the heat from the engine, that is the exhaust energy, is efficient and the lower specific fuel consumptions, right? Then the exhaust gas is supplied to the turbine at the constant temperature and the pressure. So therefore the turbine will be runs in a higher efficiency manner. So the engine speed is not limited by the pressure waves in the exhaust pipes. So these are all the advantages, and we have some disadvantages also, right? In order to maintain, right, in order to maintain the constant pressure, so we can use the larger pipes, we can use the larger exhaust pipes, right? So the scavenging is not efficient one, right? So at the part of the load, the engine of the turbine, it reduces the partial admission of the turbine, right? So and it will and it does not make a full use of the high kinetic energy which is passing through from the engine, that is the exhaust gas, right? Gas leaving from the exhaust port, right? So the loss in the mixing of the high velocity gas with a large volume of the low velocity gas which cannot be required, right? So it cannot be recovered, right? Then the response time of the system, it may get some low, right? So it will get some poor. Why? Because of the slow acceleration against the load of the engine, or the load will be increased, right? So these are all the advantages and the disadvantages. And we have the second method, that is the pulse turbocharging, right? So in this pulse turbocharging, the considerably the part of the blowdown energy is converted into the exhaust pulse as soon as the exhaust valve opens, right? So these pulses are fed to the turbine through the narrow exhaust pipe, right? So by the shortest possible route to the turbine, so where the energy will be utilized, right? So the large proportion of the energy is thus recovered, though towards the end of the exhaust, the pressure in the exhaust pipe drops below the scavenging, and the large air pressure making the scavenging quite easy, right? So the separate exhaust pipes are used. The separate exhaust pipes are used. So the exhaust processes of the various cylinders is does not in and that it does not interference, that it does not interference with another one, right? So in this diagram also you can see the the separate exhaust pipe will be used, right? So this type of is called the pulse turbocharging, and here also we have some advantages and the disadvantages, right? So for the advantages, the space required is very less. The space required is very less due to the short and small diameter of the exhaust pipes, and it is comparatively the better scavenging is obtained at the low head due to the reduced pressure and below the scavenging pressure at the end of the exhaust pipe, and the large air pressure is making the scavenging is quite easy, right? So the recovery of the exhaust blowdown energy is more efficient than the previous one, that is a constant pressure turbocharging system, right? Then the separate exhaust pipes are used, right? The separate exhaust pipes are used so that the exhaust process of the various cylinders, right? So it does not interfere with any other one, right? So we are using the separate exhaust pipes, right? So these are all the advantages, and we have some disadvantages also. So at the high pressure ratio in the turbine, so the recovery of the energy will be somewhat less, so it will be a poor one, right? So the complicated inlet and the exhaust pipes, right? Why? Because the arrangement of the pipe is needed for the multi-cylinder engines, right? For the multi-cylinder engines, it may be some complicated the manifold, that is the inlet manifold and the exhaust manifold arrangements, right? Then the length of the pipe and the engine speed is limited, right? So we can't use the more length of the pipes, right? So it will get some losses, right? So the scavenging process is distributed. The scavenging process is distributed if the waves have to travel a long distance to reach the turbine, right? So these are all the disadvantages of this pulse turbocharging, right? So this pulse turbocharging is also called as the Bush type of the turbocharging, and we have the pulse converter, right? So and we have the pulse converter also, right? So at the constant turbocharger will have a lower efficiency at the part, sorry, right, at the part load, and it requires the steady flow for the maximum efficiency, while in the case of the pulse turbocharger turbine, it operates at a relatively very lower efficiency, right? Lower efficiency due to the partial admission of the operation, and the recovery of the heat, the recovery of the energy is a very poor one, right? So however, the pulse turbocharger has a good part of the load, good part load efficiency, and also provides the good scavenging and in order to utilize the advantages and to avoid the disadvantages or the drawbacks of the both the earlier one, that is a constant pressure pulse converter, right? So this sorry, pulse turbocharger, right? So we can avoid the drawbacks, right? Then we can achieve the pulse converter turbocharging in the combination of the previous two, the constant pressure turbocharger and the pulse turbocharger, right? So here we have a different branch of the exhaust manifolds, right? So which is connected together in a specially designed venturi junction, right? So the exhaust manifold may be a different one, the separate pipes will be there in for the exhaust manifold, and the all the exhaust manifold will be collected at the end of the specially designed venturi junction will be there, right? So through the venturi the turbine will be runs, right? So the power output will be high. So we are using the venturi junction. So what will happen, it will reduce the pressure and it will increases the kinetic energy, right? So due to the nozzle function, we can increase the velocity of the exhaust gas, so the kinetic energy will be increases, so it will create a sufficient effect in the exhaust line, right? And it will help in the scavenging process of the engine, right? So the diffuser, right, the shape, the nozzle shape, right? So nozzle and what is the difference between the nozzle and diffuser, right? So shape will be the opposite one, right? So the pressure, so for the diffuser the pressure will be gradually increases, right? So if the nozzle means we can reduce the pressure and we can increase the velocity, right? So in the stabilization we are using the diffuser section, right? So for the diffusion section what will happen, the velocity will be reduces and the pressure will be increases, so the pressure will be gradually increases at the higher pressure exhaust is supplied to the turbine. So what will happen, the pulse converter system gives the quick response to the engine, right? So it is very suitable and it is very efficient one for the part load condition of the any engine and for the low pressure ratio of the turbines also, right? So these are the three methods, which is used for the turbocharging one, right? So we have know what is the turbochargers and what is the superchargers, right? So either it will be clear for you, whether it is clear. So what is
Yes,
for
sir.
turbocharger and what is supercharger, right? So for the we have more terms in the turbochargers and superchargers, but in our syllabus only they're given the limited, right? So only introduction about the turbochargers and superchargers, that's our syllabus, right? So that's why we stopped here, right? So otherwise if we have n number of classes, additional classes means we can see the more terms in the turbochargers and the superchargers, right? So up to this we can finish the unit 3, right? Up to this we can finish the unit 3, right? So in this unit 3 what are the terms we have seen, what are the terms we have seen, anyone, what are the terms we have seen? So for the unit 3, so first we start with the working and the construction of the diesel engines and the fuel feed system to the diesel engines, right? Fuel feed system to the diesel engines we have seen, and the fuel atomizer and the different type of nozzles and injector pump, right? Jerk type pump, the distributor pump that we can see and we discussed. Then the knocking tendency, that is the combustion stages we have seen, and the knocking in the CI engine we have seen, and the different type of the combustion chamber design, right? So the combustion chamber design we have seen, and the introduction about the superchargers and the turbochargers we discussed, right? So these are the terms will be there in the unit 3, right? So do you have any doubt in this unit 3? Do you have any doubt?